Welcome to Understanding Satellite Communications, a series of instructional video programs that provide the viewer with a comprehensive learning guide to the satellite industry. Each title in this series focuses on a particular aspect of satellite communications. The separate titles examine one area of this complex industry in an easy-to-follow manner that is suitable for the training of managers, operational staff, and other non-technical persons. This program is hosted by Tim Schroyer, Vice President of Vertex Satcom Systems. Vertex is a manufacturer of turnkey satellite communications networks and earth station systems. Mr. Schroyer was formerly with the Defense Communications Agency. There, he supervised all United States long-haul military and government communications in the Pacific area. Mr. Schroyer brings a high level of experience and expertise to this subject, and he was instrumental in the development of this program. We now take you to Essential Satellite Communications and Mr. Timothy Schroyer.
Welcome to Essential Satellite Communications. In this program, we'll explain and illustrate the following. The satellite circuit, the pathway of all satellite communications. Satellite orbits, spacecraft design is related to the satellite circuit. Two varieties of satellites, bent pipe and processing. Satellite frequency bands, where satellite transmissions exist in the electromagnetic spectrum. Microwaves and why they're used in satellite communications. Frequency reuse and coding. Information flow, bandwidth, and noise reduction is related to power levels in the satellite circuit. Digital technology in satellite communications. Television and transmission standards. Scrambling techniques. Future technological advances in satellite communications. The satellite circuit has three essential parts: an Earth-based uplink antenna, the space-based satellite transponder aboard the satellite itself, and an Earth-based downlink receive antenna. Radio waves travel at the speed of light, and geostationary satellites are about 40,000 kilometers above the equator. So the time it takes the signal to travel from the uplink antenna to the satellite and back down to the Earth is about a quarter of a second. There are many geosynchronous orbits, meaning the orbit is synchronized to the rotation of the Earth, but there's only one geostationary orbit. Both geostationary and geosynchronous orbits allow objects in their orbits to rotate in sync with the Earth's rotation. But the geostationary orbit, the most desired orbit for long-life, large satellites, is directly above the equator. The geostationary orbit requires some on-orbit adjustment, but it eliminates tracking requirements for Earth stations. It is, therefore, the ideal orbit for least expensive operation, long duration, and maximum coverage. Let's back up a little and take a look at the frequency bands allocated around the world by the ITU for satellite communications. We can look at this diagram and see that there are distinctly different types of satellite services allocated to different bands. Specifically, most satellite communications fall into three different applications: the Mobile Satellite Service, or MSS, Direct Broadcast Satellite Service, or DBS, and Fixed Satellite Service, or FSS. Digital modulation techniques used today include changing the phase of the carrier wave. There's biphase shift, or BPSK, quadrature phase shift, or QPSK, and now even 8-phase shift, or 8PSK. In today's communications world, almost all signals are digital and thus reduced to transmitting bits, regardless of whether those bits were generated from a voice, data, or video information source. If it's in the air, it's most likely a digitally encoded signal. Satellite communications systems are now benefiting from larger, heavier satellites that can produce more power and provide stronger signals on the ground. At the same time, smaller, lighter satellites in unusual orbits are providing some innovative new services. All the while, digital signal processing techniques make it possible to transmit more voice, more data, or more video in the same bandwidth and with the same power. The end result is that every day satellite communication systems are capable of providing more and more service all over the world. Satellite communications remains the fastest way to establish new and exciting communication services in remote regions of the world, as well as the best way to broadcast a single signal to the most people. Even as the Internet provides two-way communication to individuals all over the globe, satellite communication is one of the principal ways the Internet is carried. It remains the most significant tool to have revolutionized global understanding by bringing people closer and closer together. Satellite communications let the current generation of inhabitants of this planet see the first human being ever set foot on the moon. With satellite communications, not even the sky is the limit. Watch out, there's lots more to come. Thank you for watching this program. I hope that you now have a better understanding of essential satellite communications.